TomoNews presents Wind Turbines and Wind Power.
Japanese engineer develops turbine that loves typhoons. A new type of wind mechanism being developed in Japan is designed to not only harness power from the wind, but also to be particularly effective during typhoons. A typhoon turbine created by a Japanese engineer consists of 3 vertical blades and a central rod. It has an omnidirectional axis so that it can respond to wind coming from every direction. The turbine makes use of the principle of the Magnus Effect. Air curves when passing by a rotating object, and the downward deflection of the airflow produces a lifting force that counteracts the force of gravity, enabling the object to remain airborne. The blades are controlled by the central rod, which can be tightened to slow down or stop the blades completely regardless of the external forces. Under normal circumstances, the Typhoon turbine can achieve about 30% efficiency, while a conventional wind turbine can achieve 40%. However, conventional wind turbines can be damaged by typhoons, while the Typhoon turbine would still function normally in a large storm. The designer of the Typhoon turbine believes a single typhoon would be able to generate enough energy to power Japan for 50 years. According to the Japan Guide, about 7 or 8 typhoons pass over Okinawa Prefecture each year, with about 3 hitting its main islands. If the Typhoon turbine is proven to be functional under extreme weather, then Japan could harvest a significant amount of energy to power itself for a long time.
Plan for the world's largest floating wind farm gets the green light. Scotland's notoriously strong winds could pan out to be a blessing in disguise after the Scottish government recently approved plans for a floating wind farm. Existing offshore wind turbines, which need to stand on concrete or steel foundations, are expensive if anchored to depths greater than 40 meters. Instead of anchoring turbines to the sea floor, Statoil, a Norwegian energy company, plans to build a floating wind farm 15 miles off the coast of Peterhead, Scotland. 5 floating wind turbines will be installed offshore. The base of each will consist of a floating steel tube filled with ballast. Each wind turbine, measuring about 258 meters high, is then tethered to the seafloor 90 meters down by 3 moorings. Because they're not actually attached to the seabed, these types of wind turbines are cheaper than traditional ocean turbines and can be placed in deeper waters. Each of the 5 wind turbines will have a 6 megawatt capacity. Together, the 5 will be able to power an estimated 20,000 homes. In 2014, Scotland generated 11,740 gigawatt hours of power from wind, which nearly made up a third of Scotland's total energy consumption. Statoil's goal with this $232 million pilot project is to demonstrate global market potential for turbines.
Dozens of birdwatchers who had traveled to the northern Scottish island of Harris to see a rare bird were left crestfallen when they witnessed it fly into a wind turbine and die late Wednesday afternoon. The White-throated Needletail, the world's fastest flying bird, was first spotted by 2 Northumberland birdwatchers on Monday. Word got out via online service Rare Bird Alert, which notified enthusiasts of the sighting. By Wednesday, almost 40 twitchers had turned out to watch the bird, which winters in Australia and breeds in Asia. Amateur and expert ornithologists alike relished the sight. Until, that is, the bird flew directly into one of the blades of a nearby wind turbine. It is believed to have died instantly. There have been only 8 recorded sightings of the white-throated needletail in the UK in nearly 170 years.
Unique wind system may be key to bringing electricity to developing areas. A Minnesota wind turbine company has signed a licensing agreement that will see its energy technology be used in the Netherlands. Sheer Wind has a patented system of harvesting wind power that can produce 6 times more green energy than traditional systems called Envelox for increased velocity. The funnel-shaped Envelox system captures wind from all directions, even with speeds as low as 2 miles per hour. The wind is then funneled through a duct where it picks up speed. The accelerated wind is delivered to the generators on the ground level, where its kinetic energy is harnessed to produce electricity. Any residual wind will be returned to the environment. Unlike conventional turbines, Envelox keeps its generators on the ground rather than on top. This allows it to produce 600% more power. With its capabilities, the powerful device can be used not just commercially, but also in developing nations and in areas where electricity is not readily accessible. The biggest ever wind farm is set to be built off the British coast. The UK government might be gearing up for a so-called hard Brexit, but that doesn't mean it's stopping work with European companies. The world's largest wind farm is set to be built 90 miles off the British coast by Danish energy firm Dong. When completed in 2022, the wind farm will have a capacity of some 1.4 gigawatts. According to Dong, that's enough energy to power some 1.3 million British homes. The project is expected to create 2,000 jobs over its duration. Amazon is constructing a wind farm that contains 100 turbines. Amazon has announced a new project that aims to result in renewable energy that will power thousands of homes across America. Amazon Wind Farm Texas is underway. The diameter of each wind turbine will be 2 times the wingspan of a Boeing 747 plane. The farm in Scurry County, West Texas, will be comprised of more than 100 wind turbines in total. The wind turbines will generate an estimated 100,000 megawatt hours of wind energy every year, enough to power close to 90,000 homes in the United States. The latest development by the company, along with 4 other clean energy projects, should generate 2.6 million megawatt hours of energy each year to power more than 240,000 homes.
Floating Atlantic wind farm could meet the world's energy needs. Would you believe it if we told you the entire world could be powered by a wind farm in the Atlantic? We're not blowing hot air here. According to a new study, building a deep-sea wind farm the size of India that stretches across the North Atlantic could meet the whole world's power needs. Land-based wind farms can produce around 1.5 watts per square meter, while a wind farm in the Atlantic would be able to generate 6 watts per square meter. Several engineering challenges would have to be overcome. A deep-sea wind farm would have to operate in remote and harsh conditions, where waves frequently exceed 3 meters. Laying transmission cables that stretch across the ocean floor, then connect to floating turbines in open ocean, would be another obstacle. A project that big would also require international cooperation and a whole lot of money. Good thing we all get along so well.
Spanish energy giant to build Mexican wind farms. Spain's Acciona Energy announced on Thursday it had won a contract to provide wind turbines for 2 power plants in northeastern Mexico. Spanish energy giant Acciona has said it will build the 2 wind farms near the Mexican town of General Bravo in Nuevo León state. The Ventica and Ventica 2 wind farms will each feature 84 3-megawatt wind turbines. The projects will add a 252 megawatt boost to Mexico's wind power capacity, which last year reached 1,992 megawatts according to Bloomberg. They will also help Mexico towards meeting its target of generating 35% of its electricity needs with renewable energy by 2025. Construction of the farms will begin later this year, with operations expected to start in mid-2016.
German researchers have developed a sensor system designed to cut light pollution from wind turbines. The system switches on the turbine's anti-collision lights only when aircraft approach. The system uses passive radar sensors to pick up existing local radio station frequencies, including DAB+ and DVB-T, to determine if there is an airplane in the vicinity. Sensors attached to the mast receive the signals, and the data is processed within the mast. The protection of the passive radar network spans the wind farm like a parasol. The radio signals are reflected off airborne objects, and an algorithm processes the reflections in order to determine their distance, position and velocity. The collision warning lights only switch on when a plane passes within a radius of 4 kilometers and below an altitude of about 700 meters. The team is currently optimizing the signal detection algorithms in anticipation of the system to be fully operational by 2015. With the recent completion of the large Eshegoda wind farm, Ethiopia is solidifying its role as sub-Saharan Africa's biggest renewable energy producer. Ethiopia recently completed the Eshegoda wind power project, bringing 84 massive wind turbines online. Each turbine is close to 80 meters tall and generate power using basic windmill technology. Wind turns the turbine, which use gears and a generator to convert the energy into electricity. Underground cables lead to a substation and transformer. before the electricity is transmitted to the population centres. Ethiopia currently produces around 2,000 megawatts of electricity, but hopes within 2 years to boost that to 10,000 megawatts, roughly the annual usage of a single US household. With more wind farm projects in the pipeline, officials hope one day to export electricity to neighbouring countries. Several more wind farms are scheduled to be completed soon, which could help Ethiopia meet its goal of becoming a middle-income, carbon-neutral nation by 2025.
MIT scientists have patented a new method of increasing the efficiency of offshore wind farms. Excess energy generated by offshore wind farms would be used to pump seawater out of giant concrete sphere anchors. When wind turbines are not generating power, the concrete spheres will fill with seawater, turning the turbine connected to the power grid. The concrete spheres will be able to maximize the energy produced by offshore wind farms.